Welcome to the experiment 3. In this experiment, I have taken 3 sounds: fan sound, rain sound, and speech sound, and I calculated statistical parameters for these sounds: mean, variance, kurtosis, and skewness. Coming to the first 30 minutes of data, and for fan, I created 4 matrices: mean, variance, skewness, and kurtosis to store the statistical parameters. And my block duration is 1 second, so I have 1800 samples, and I took sampling frequency to be 16,000. Here I audio read the fan sound and calculated mean, variance, skewness, kurtosis for each sample and stored in the matrices I have created. Next, I calculated the min and max for various statistical parameters for fan sound to know the threshold range. And next, I plotted the histograms for these statistical parameters. And coming to train sound, similar to the fan sound, I created again 4 matrices to store mean, variance, skewness, and kurtosis. And similarly, I calculated the min and max for each statistical parameters and plotted the histograms. And coming to speech, I also created 4 matrices for storing mean, variance, skewness, and kurtosis, and found min and max for various statistical parameters and plotted their histograms. And coming to the second 30 minutes of data, I created confusion matrices for mean, variance, skewness, and kurtosis, a 3x3 matrices. And first, I audio read the fan sound. Next, I calculated the mean for the second 30 minutes data of fan and check whether it lies in which threshold range, means how many samples lie in the range of fan mean and how many samples lie in the range of train mean and how many samples lie in the range of speech mean. And similarly, I done it for variance, skewness, and kurtosis. And next, I audio read train sound, and similarly I calculated for mean, variance, skewness, and kurtosis. And I also did it for speech sound. I calculated the mean of the second 30 minutes data and check whether how many samples lie in the range of fan mean, train mean, speech mean. And similarly for variance, skewness, and kurtosis. And the output, I got it as these are the mean and max of various statistical parameters of 3 sounds. And MM is the confusion matrix for mean, and VM is the confusion matrix for variance, SM is the confusion matrix for skewness, and KM is the confusion matrix for kurtosis. And the diagonal elements gives the accuracy of that statistical parameter of that sound. And coming to the GUI, I took 3 axes to plot the statistical parameters for fan, train, and speech. And here I created a table to get the confusion matrix, and I created a pop-up menu to select the statistical parameters and a push button to get the data. And when I select the mean statistical parameter, I got this, and this is the histogram for mean of fan for the first 30 minutes of data, and similarly for train and speech. And here is the confusion matrix, and similarly we can get it for variance, skewness, and kurtosis. And here from this data I can say that mean gives the more accurate than variance, skewness, and kurtosis. This is the third experiment. Thank you.